Hello, salam sejahtera. So today we are going to present our PBL, program-based learning, under subject BEEA 2374 Embedded System. And our project title is Advanced RFID Safety Bunker. So our group member is THANASUGANG, ANAK, DOUGLAS, ANTON, which is me, DOMINIC, LAADE, and MAXSTEIN bin EDWIN. So for the introduction, the title of our program-based learning (PBL) is Advanced RFID Safety Bunker, which is simple design of Arduino-based system product that consists of ultrasonic sensor that detect presence of person in distance, and also the LCD to display an instruction followed by RFID tag and reader to access the phone keypad the correct password to allow the door lock motor unlock the door. So the port use at professional and Arduino IDE program software is we use to design our system and simulate the technical output. And the advanced RFID safety bunker is a device that commonly used as an advanced security system. It can be used as a smart lock for the deposit box, bunker, door, and so on. For the system, it requires double verification, which is through card, which is RFID, and password. So there's two combination that we use in the system. This makes the system much more safety as it is difficult to break. So you, the owner, will not have to worry if someone is trying to break your bunker or your safety deposit box. But for this project, we are focusing to apply the system into the bunker. So list of material. What material that we use for this project? So basically, we will use the Arduino board Uno, the jumper wire, breadboard, and then the sensor is we use the ultrasonic sensor and RFID tag and reader, and then we use the LCD, which is to be more specific, we use the liquid crystal I2C LCD, and then we use buzzer, keypad, LED, and servo motor. And the other list of material that we use is the silicon NPN transistor with the code is B6547BP, and resistor and push button.
I'm MAXSTEIN bin EDWIN, which would like to present about our project system operation. Okay, in our project design, we include 3 inputs and 4 outputs. The first input is our ultrasonic sensor, which is emitting sound wave and reflect onto an object or user. Then transmit response echo as output to our first output, which is LCD display shown a text "Welcome to the secret bunker." Therefore, we present the first input sensor as push button switch in our simulation design. The first input that we use is RFID tag and reader, and we represent it also as push button switch in the simulation to access the system program. As the tag is successfully scanned through the RFID reader or through the simulation, we will push once on the switch. The second output will generate again to the LCD display, which display enter password. The third input function as reinforced security to the bunker door will still need to key in 4-digit password that's being set 8484 by using the phone keypad. As the password key in and the phone keypad is correct, the output will transfer the input data to the LCD display and display text written "Welcome boss, door open," followed by the green LED turn on. The servo motor that acts as bunker locker will be unlocked. But if the password is wrong, the servo motor will not operate. The red LED will turn on and the LCD will display wrong password. Try again, attempt remaining. Then the user has to key in the password again. The user has 3 times attempt to key in the password. If those 3 times attempt still fail, the buzzer will buzz. Red LED will blinking and LCD display access denied. Then the process system will end. The user can clear their password by keying star or hashtag. After the user is successfully entering the bunker, the user can press the reset button so that the system will start from the beginning. Okay, here we declare the RFID and ultrasonic sensor. We replace it with push button. This is because there is no RFID sensor so far in the Proteus. Meanwhile, for the ultrasonic sensor, we replace it to the push button because we are unable to make the ultrasonic sensor detect any object or body in the software. Okay, now I will continue explanation for our system project. Okay, first of all, as the system start, it will declare all the program library. Then the ultrasonic started to detect the user body. Followed, transfer the data onto the LCD display, which will display a text written as welcome to the secret bunker. Followed, the user will scan the text onto the RFID reader. Proceed, the LCD will display entering the password. Okay. As the user entering the password through keypads, the system started counted, and if and reach a decision point, which is the true and false, as the user decided to reset the password as it's not confirmed that the password is true or correct entered, the user may key in hashtag or star to reset back the password entered, and the user will continue at the fourth part of our system program, which is LCD display to entering password. As the user continue correctly entering the password, the system will detect the password. Okay, start counting to the total equal to 0. And if the password is the password detected false, it will start the decision either start the decision in the 3 attempt. Okay, if the decision is false, okay, the password will show the LCD display access denied. Okay, red LCD blinking and buzz for 7 times, and our system will end. For 3 times attempt is false. Okay, then if it's true, again the decision is true after the effort attempt is wrong. Okay, the LCD will display wrong password. Try again, attempt remaining. Okay, wait, ready, turn on. This will continue about 3 times wrong attempt. If the 3 times attempt is wrong, we directly to the false decision. Okay, if the user correctly attempt either in the both 3 before the 3 attempt, okay, LCD display welcome, pause, and door open. The process proceed to the green LED turn on. Then the servo motor operate and shut down in 5 seconds. Okay, end of the process.
Next is the circuit, the program, and the simulation result. So I'm Dominic LAADE, and I will explain all the components that we use in the circuit and the program and the output that we get for this project. So first one is of course the Arduino Uno, and then the second one is LCD display to display all the message, the password, all that we want to display. And then this device here is for expansion input output port for Arduino Uno, because Arduino Uno cannot provide all the I/O port for the device that we use here. There's too many devices that we use. And then down here we have two push button, which is for sensor and for RFID. So this one actually we cannot simulate the sensor and RFID, so we replace it with push button. So if the sensor detects someone, it's considered the push button is closed, and then same with RFID, if it scan the card correctly, and then it's considered closed. So, and then to the right here we have keypads for input the password, and then up here we have two LED, which is green and red. Green for correct password to proceed, and then red is for the wrong password and alarm system. And then to the left here we have motor, servo motor. This motor is consider a door for the bunker. So if the password is correct, the motor or the door will open. That means the motor will rotate. And then the buzzer for the alarm. So just imagine if the input password is wrong 3 times in a row, and then the alarm system will turns on, the buzzer will beep, will buzz, and then at the same time LED green, LED red also turns on, blinking. So that's all for the circuit. Alright, next is the program for the circuit. Here I will briefly explain what it does, because try to save our time to explain. So the library, and then the key for keypad, and then the password here is 8484. This is the the correct password. And then position 0, and then this one is for the port, and then mapping the keypad, and then total to determine the wrong attempt, the attempt, total attempt before the buzzer turns on, the alarm, and then three time attempt. And then the setup here is set all the input output that we need. And then so the condition, so the first condition is the button state 1, the sensor and RFID. So the button 1, the sensor high, the RFID low. That's mean when the owner is stand in front of the bunker, someone stand in front of the bunker, and then the LCD print will say welcome. So the means the system turns on if someone stand in front of the bunker. So if not, then turn off lah. So and then if button state 1, button state 1 is high, button state 2 is high, that's mean the person is standing there and then scan the RFID card. So that's mean the LCD will ask enter password, and then get the password. If here is we set the star and hashtag is the reset. So if they try to if they enter star or hashtag, that mean the system will reset the password. So that's mean we need to enter once again. So or if he noticed that he entered the wrong number, and then he can press the star to reset. So if press password, press is equal to password, the position will plus, and then if press is not equal to password, the wrong is become higher, plus, the wrong is plus. And then if position is equal to 4, and then if all the password is entered, 4 digit password is entered, and then if wrong is greater than 0, that's mean this one, if press is not equal to password, 8484, and then it will say wrong password, and then try again, and then attempt remaining. So this will display the attempt remaining that here left. And then if the position is 4, all the 4 digit password is entered, and then wrong also 0, That's mean it will say welcome, the door has been opened, and then green LED will high, and then green LED will low for 3 seconds. So the door has been opened. So if total is equal to 0, when the atom is equal to 0, the LCD will access denied, and then buzzer will beep. So this is the buzzer beep, and then LCD clear, and then exit the system. So else LCD clear, exit the system. This is when the sensor is not press any, or the RFID press, the sensor is not detect, and then it also considered exit. Alright, the buzzer beep will turns on at 7 times. The condition is below than 7, so 7 time beep, and then the system will turns on off. And then the void door open, this is for the servo. For if the correct, the servo motor will rotate at 180 degree, and then after 5 seconds the motor will rotate at 0 degree, and then LCD clear, and then the system is shut down. Alright, that's all for the program, and that's all for the program. Okay, after explain about all the component that we use and the program code, now let's see how it goes, the simulation result. So first, let's maximize this one, and then let's run the simulation. So let's say the owner is come to visit the bunker. So when the owner stand in front of the bunker, the sensor will detect the person, the owner. So let's say the sensor is already detect, so it will turn on. So the LCD display will come to the secret bunker. So here, after detect, the system turns on. So the owner scan the RFID card, so the push button will turns on. So and then the LCD display will ask the owner to enter the password. So let's say the owner enter the right password, so it will become 844, and then 84. So it will say welcome. So the LED will turn green, LED green turns on, and then the rotor will rotate, and then after 5 seconds, and then the rotor will become 0. So that's if the owner enter the right password. So let's reset. So the second situation is when someone is try. Alright, I'm sorry, let's reset, and then this one is turned off. So the second condition is when someone is trying to sneak in our bunker. So when the thief is enter standing in front of our bunker, the sensor will detect the thief, and then the sensor, the switch turns on, and then will come to secret bunker as usual. So let's say the thief already get the RFID card from the owner. So when the thief scan the RFID card, so the RFID card will turns on lah, the button, so it turns on. So the LCD display asks the thief to enter the password. So this is the moment that the thief don't know what the password is. So let's say the thief try the first time, the first attempt. So the thief enter 9, 6, 8, then 7. So and then the LCD display will say wrong password, try again, attempt remaining is equal to 2. At the same time, the LED red turns on. So and then the thief try to enter the password once again for the second time. So 6, 4, 1 and then 2. So same again, wrong password, attempt remaining 1 and then LED turns on, LED red. So yeah, there is one remaining attempt for the thief. So and then he try again for the second time. So 4, 5, 6, 7, and then attempt remaining is become 0, and then after several time, yes, the buzzer will turn on, the alarm turn on, access denied. So this will continue 7 times and then the system will turn off. Yes, it will turn off after 7 times. Turns on, buzz 7 times and then LED red blinking 7 times and then the system will off suddenly. So that's all for the simulation.
Okay, so for the conclusion of this project, after finish doing this project, PBL, Program Based Learning, we learn about the application of the embedded system through Arduino and Porteus software. We are able to learn about the LCD I2C coding and library. From there, we discover about the function of the liquid crystal I2C library at Arduino IDE. After doing a lot of research and try and error method, we finally managed to get the correct and suitable circuit diagram for our project, which is Advanced RFID Safety Bunker. So most of our coding, we use if-else condition to simulate the program. At the end, we gain a lot of knowledge about the servo motor, transistor, buzzer, liquid crystal liquid crystal LCD, and so on. And our hope that this project is not only can be applied to the bunker, but for the variety of system that require an advanced security application. This system can be improvised with a lot of high-end technology that appear nowadays, such as fingerprint, eye retina scanner, and face verification, which will make the system much more secure. So that's all from us. Thank you.